The Sky This Month with your host, Dave McDonald.
Welcome to The Sky This Month. I'm your host, Dave McDonald, and this is June 2025, and we have our great show for you, as always. Behind me, clearly you can tell Stonehenge is there with the sun in one of the solstices, the summer solstice in this case, which we want to mention is coming up on June 20th this year, and in the East Coast time zone, 8:55 p.m. is the summer solstice, and that is the time when the sun will reach its highest point in the sky. It'll bounce off the Tropic of Cancer, so to speak, and hard to believe it's going to start making its way southward again. So don't miss the summer solstice, June 20th. But plenty of things to talk about in the night sky, so let's get on with it right away. So I want to show you, we're jumping ahead to June 19th. And June 19th is, I've chosen because this is in the morning sky. The other images I'm going to show you will be in the evening. But the morning sky features Venus, and Venus is going to be at its brightest June 1st. So if you're right at the beginning of the month, you're catching Venus at its brightest, which is awesome. But Venus is going to be available for months to come in the morning sky. So Venus is available to see. With binoculars, you might catch a glimpse of Uranus, which is right near the Pleiades star cluster. But I'm choosing the 19th because we have the moon hanging out with Saturn, and that would be a pretty sight. But again, for the first half of June anyway, you have Saturn available, and the moon is going to be close to Saturn on June 18th and June 19th. So that's why I chose that date for you to enjoy the morning of Venus and Saturn with the moon on the 19th. Then let's skip ahead to the evening, and we're going to jump back to June 9th. Okay, so June 9th, again featuring the moon. It looks like it's full here. It's not full, and neither was it full in the previous image. It was very crescenty. And the reason I'm choosing June 9th for this is that you have now the moon close to a star called Antares. This is the constellation of Scorpio or Scorpius, and the stinger in at this time in the southeastern sky, the southeastern sky, goes below the horizon because we're at about 10 o'clock at night. So the later you stay up, the higher Scorpius will appear in the sky. But the moon is hanging out near this red star, Antares. Antares means I'm not Mars, because Antares has a reddish color and is often the similar brightness to Mars, and sometimes the orbit of Mars takes it so it comes really close to Antares. And somebody wanted people to know this one is not Mars. But later on in the show, it's going to knock your socks off. I'm going to give you an idea of how big that star Antares actually is, representing the heart of the Scorpion. Next, we're going to go ahead to the 17th of the month. And the 17th of the month, overhead you can see the Big Dipper. And the Big Dipper is prominent in an overhead position, and you can't miss it. And as pointed out last month, I want to show you the arc of the handle of the Big Dipper arcs to this star here called Arcturus. So you arc to Arcturus, and Arcturus is a very bright red giant. So magnitude 0, actually 0.15. But it is really bright, but it is also huge. And towards the end of this segment, I'm going to show you how big Arcturus is as well. Then, after you arc to Arcturus, you can spike down to Spica. Spica is a neat blue star, a white blue star, and it is a magnitude 1 star. So that means Arcturus is about 2.5 times brighter than Spica is. But Spica, beautiful through a telescope, and again is a blue-white star. Blue-white are the hotter stars, the hottest stars, and Arcturus, being red, is among the cooler stars. Red meaning cooler, and white, blue, is the hotter stars. And then in the middle, you have orange and yellow, like our star is yellow, and white. So what I want to show you now is to build an ice cream cone, because it's summertime. And we've arced to Arcturus, which is here. And Arcturus is officially the brightest star in the constellation of Boötes, the herdsman. I have never liked the artwork for the herdsman, so I'm not going to bother to show you the artwork for the herdsman. I just haven't found a good one. But what I do like in the summertime, if you can picture Arcturus being the bottom of an ice cream cone and building it up this way here, where this is like the cherry on top of perhaps an ice cream sundae, Arcturus is the bottom of the ice cream cone. And I wanted to also have this image here because one of the features is Mars, and Mars is hanging out on this date by Regulus, which is the heart of the lion. Regulus is the heart of the lion, and it's really neat to see the two stars, well, the star Regulus and the planet Mars, so close together. And this is again around 10 o'clock, and this is on June 17th. So next slide then, keeping Mars and Regulus in view again, just for reference so that you can see them here. You have the head of Leo the lion, which is this back, I call it the backwards question mark. And we come over to this triangle shape. The end of the triangle is Denobla, the tail of the lion. And once again, off to the left of your screen, you see the star Spica. Now, we're looking at the star Arcturus building with the lines, the ice cream cone. And you can see it here. And you can see the lines that go up to the top, where if you have a sundae, you can have a cherry on top. And this is the side here. And you can use these couple bottom stars around here. Perhaps they're the bottom of the sundae dish. So you arc to Arcturus. Here's the Big Dipper. Arc over to Arcturus, and then spike down to Spica. Spica represents the sheaf of wheat, or an ear of corn, in Virgo, the Virgin. And then I want to mention one more time, because we want to be keeping an eye on it, but just to the left, as you look up in the sky of the ice cream cone of Boötes, you see this tiara shape. And this is the constellation of Corona Borealis, the northern crown. And there's a star about where my finger is there that you can't see. It's a magnitude 10 star, but it's T Corona Borealis, or CBR, and it is going to explode in the not too distant future. We're not sure when, but it's going to come into sight probably as bright as this star here is bright. So that's something to keep a watch in the news. Should be bright enough for a few days to be able to see this new star appear, and it will be a nova of a star that is on roughly an 80-year cycle or so. So now, this is our sun, the planet Jupiter. Our sun compared to Sirius, which is the brightest star in the night sky. And then we have Pollux, one of the twins, Castor and Pollux. Pollux is one of the twins. And then the star that we arc to, Arcturus. Look how huge Arcturus is when you compare it to the sun. It is amazingly big, and it is amazingly red, and it is a cool star, but it is just huge. And now take a peek at this. Here's Arcturus down here, that huge star that we were looking at, and compare that with Betelgeuse, which is the upper left star in Orion as we look at Orion. And then Antares, the heart of the Scorpion that we started talking to, remember the I'm Not Mars star, reddish. It's so far away though, that's why it doesn't look so big and doesn't look so bright, but it is huge, and look how much brighter it is and how much bigger it is than Arcturus. And you can see in this image here, basically our sun is one pixel compared to this. So if we were to put our sun at the center of Antares, out past the orbit of Mars, Sun, Mercury, Venus, Earth, Mars orbits would be inside the star Antares. It is just a huge star. So those are some neat things to be looking for in the night sky, some stars, some constellations, and don't forget about the summer solstice on June 20th, happens at 8:55 p.m. for Eastern Time. Hey, I got a couple of friends I want to introduce to you or reintroduce to you again. We had some great times in the past on our TV shows, and so we're going to introduce them and have a little bit of a chat about some other interesting things that are going on in the sky. Well, I hope you enjoyed that little sky chat, and as promised, I have a couple of my friends here that you have seen on the show before, and they have a neat story to tell you and some neat things to talk about. So let me once again introduce to you Adam Krasnecki. Welcome to the show again, Adam.
Pleasure to be back.
And Seth Roop.
Thank you for having me.
And they've been on the show off and on since they were in my astronomy class in astronomy club years ago. But some exciting things have happened into their lives. So Seth was at the University of New Hampshire, where he graduated last year, and Adam was at Clemson University, where he finished his master's degree this year. So let's have a look at the pictures and tell us a little bit about what you studied and what went on.
So I graduated from the University of New Hampshire in Durham, New Hampshire, and I studied music performance. I was a clarinet player and guitar player.
Yeah.
I also took some astronomy classes while I was there.
Yes.
Lovely place, lovely university, and very much enjoyed my time there.
And you had, for astronomy, one of my colleagues, John Gianforte.
That's right, that's right.
Yeah, awesome. And Adam, you were down a little further south. So tell us about your experience in graduate school and what you did and what you're doing.
Yeah, that's right. So I believe I had been on the show somewhat recently after I graduated the first time.
Yeah.
With my undergraduate degree. That was in mechanical engineering. And then I was actually able to take part in a BS MS program where I could get my master's in 5 years. So I took a couple of classes that double counted, and I was able to get my master's in mechanical engineering in just 1 extra year. And believe it or not, I was able to actually get a minor in math along the way without taking any additional classes.
That's awesome.
Just because of how much math there is in the mechanical curriculum. So
you gotta love math.
Yeah, it's a lot of fun. I had a lot of fun down at Clemson in South Carolina, but I'm happy to be home.
And it's great to have you here. Again, welcome. And you guys put together some interesting things to chat about relative to the night sky and what's going on into June. So take it away.
Yeah. Well, the first thing we're going to talk about, not so much something you can see, but it's exciting news nonetheless. In the last week or two or so, our research team has discovered a relatively small object in our outer solar system that has the potential to be classified as a new dwarf planet. There's only a couple dwarf planets right now, so this would be adding it to a rather exclusive group. So what they discovered, it was a team led by Zihuan Li and Sihao Cheng, and they discovered using data, publicly available data from the Dark Energy Survey, which is a long-running study to explore and find out more about dark energy. There's a ton of publicly available data, and what they did is they reviewed a lot of this data, used some algorithms to sift through, and they found an object that they suspected might fit into the categorization of a dwarf planet. They tracked it over several years, used algorithms to filter out background noise and extra stuff. It's not really been done before. This is a very meticulous and
cutting edge.
Cutting edge, you could call it. And so what they've come up with is an object that they have called 2017 OF201, rolls off the tongue. And it's about 700 kilometers in diameter, which is fairly small for comparison. Other, like Pluto, for example, 2,300 kilometers or so, give or take. So it's a fair bit smaller than other bodies in our solar system. And currently it's about 90.5 AU in distance. However,
And what's an AU?
an AU is an astronomical unit, which is measured as the average distance that the Earth is from the sun. So it's about 90 times the distance
That's
Earth
out
to
there.
the sun. It is out there, and it gets much further
Wow.
out there. It is. It has what we call an eccentric orbit. It
Yes.
is not perfectly circular, and we'll have an image shortly that can show a little bit more of how unusual its orbit is.
And Pluto's approaching 40 AUs, so this is more than twice as far
Yes.
out as Pluto,
Yes.
and gets further, as you said.
So we've got an image that can kind of illustrate the scale of its orbit relative to our solar system. So you see this blown up image that represents our inner solar system, what we kind of think of as the solar system. And you can see this large orbital path. That is the orbit of this new object. And you can see there's a scale of 250 AU down here. So this thing gets way out there.
So what I'm circling here is basically what's in the square.
Yes.
So the square becomes this
Correct.
little piece here.
Correct.
So that makes that very elliptical
Yes.
orbit huge.
Yes. So one of the interesting things then about this is because of its relatively small size and how far away it gets from our solar system, for a majority of this object's path around its orbit, it is too faint to be observed or detected.
Sure.
So when it's really only able to be detected when it's in this very close approach to the rest of our solar system. Essentially for 99% of its orbit, it cannot be seen. So that kind of makes you think like there may be other objects of a similar nature that with their large orbit and small size, we cannot see them until they are just in the right place, and even then we have to be looking in order to see them.
It's good to be observant.
Yes, it pays off.
Nice. Okay, so Adam, you can take us a little further?
Sure. Yeah. So this dwarf planet candidate falls into the category of trans-Neptunian objects, of objects that reside beyond the orbit of Neptune. And there's a number of notable examples, of course, Pluto, Eris, Makemake, and there's several others as well. There may even be thousands of them that are just a few kilometers in diameter. As far as a candidate for Planet X, this has sort of been a mystical theory that has existed for quite some time about a body that could explain orbital irregularities, and the large majority of these trans-Neptunian objects sort of all have a very eccentric orbital path, as Seth was explaining, but they all have their long tail, if you could call it, of the orbit in a similar direction. And for a long time, astronomers have thought that this is because there's a larger mystical planet that potentially is at a far part in its orbit that it is no longer detectable by us here on Earth, that is throwing off and skewing the balance of the solar system and causing all of those other ones that we can detect to be on one side.
And as a matter of fact, you mentioned about the effect on it, and we know that the reason that we found Neptune was because Uranus, that orbit was being perturbed by something.
It's affected, right.
And so we went hunting, and sure enough, there was Neptune. And then, to make matters worse, or more exciting, Neptune's orbit seems to be being perturbed. Well, what is doing that? And so Percival Lowell sent Clyde Tombaugh to work at the Flagstaff Observatory in Flagstaff, Arizona, and said, find it. Something's bothering Neptune, and we need to find it. And on February 18th, 1930, guess what was discovered?
Pluto.
Yeah, Pluto was discovered. And so this whole idea of finding orbits not behaving the way they should, something else is affecting it. And I think Planet X is definitely a candidate for what's going on out there.
Right. And sort of one of the interesting things about this discovery itself is that since, like as Seth said, the eccentric orbit does not fit the pattern of other objects with similarly eccentric orbits, and this means that it could actually be a candidate for disproving that theory, where potentially a lot of other planets and sort of the average is more normal instead of skewed as by what we've detected so far, and that could potentially explain the reason all these orbits are here. And the reason why we haven't found any others is because, like Seth said, they could be at a different part in their orbit, that they're just too far away and too small to see. Yeah. So rather than one large planet throwing everything off, there could be a collection of smaller planets or dwarf planets like we've already found, but they could just be at parts in areas that are undetectable to us currently.
So we have an image here. This shows the very eccentric orbits of several notable trans-Neptunian objects. And so this would be like the theorized potential area of what is often referred to as Planet X, where it would be gravitationally influencing all of these, and they're all kind of facing a similar direction. They're kind of clustered, but our orbit of this newly discovered object is all the way around here.
On the other side.
So the other side of what would be expected. So that's a point of contention that the two individuals who discovered this on this team are saying, hey, maybe, we're not anything concrete, but this could be an alternate explanation as to kind of a point against the Planet X idea, and like Adam said, because it's so faint, so hard to see, there could be tons of these that we're not able to see because of their distance, their size, and the limited amount of time in which they're available to see.
Isn't science wonderful? I mean, we have these questions and different theories of what might explain it, and it just causes us to dig deeper into the amazing creation of our solar system. So, yeah, hey, how does this, see if I can say it right, 2017 OF201?
That's right.
Is that good?
That's right. Perfect.
How does it change the way we think?
Yeah, so I mean, kind of some of it we've dug a little bit into. It gives us more context for what might be going on beyond the very inner part of our solar system. When we think about our solar system, we kind of think of maybe the planets and the sun, and that's the solar system. But our solar system is a very extensive and large. It is a big place, and these objects, these TNOs and dwarf planets and asteroids, all this stuff that goes beyond the orbits of Neptune and Pluto, these are important parts of our solar system, and they're important for understanding the system as a whole. Yeah. What's going on gravitationally and how all these orbits are interacting. So like we said, this gives us an idea of maybe there's a lot more of these objects that could help us learn a lot more about how our solar system functions.
Yeah, and in the past we've been lucky, as David said, that planets had been discovered. A single planet had been discovered by the perturbance of another's orbit. And in this case, potentially it could change to be more of a collection of smaller objects causing a similar perturbance, which hasn't been seen before and may open the door to many new discoveries because of it.
Yeah, that's awesome. And then we'll send a spacecraft out there.
Get some pictures.
Which will get some pictures for sure.
Yeah, and so that's kind of our. It's pretty interesting. It's new. This is a recent discovery. Yeah. I would expect to hear more about this in the coming months, even years, and so on. It's going to be ongoing. And
especially the theories and speculations around it as well will be interesting to hear.
Yes. Yeah. Well, thanks for bringing that to our attention, because like you said, this is a new thing, new ideas, and that's what this show is all about. What's the latest and the greatest in our solar system? All right, so what are a couple other things that we have to look for here in the month of June?
We've kind of just brought a collection of things to round off our discussion of some, David, you already discussed several notable things to look for in the sky, but we brought a couple other things to look for.
Starting off right in June 1st in the morning sky, you're going to see Venus at its furthest western elongation, which means it'll be furthest to the west away from the sun, which would give it you know, as long as you can get a time where you can see it, would be the furthest away from the sun, the least influence of the sun, and be able to see it in better lighting than usual. So,
unless people be confused, it's in the eastern sky.
Eastern sky, right?
It's the furthest west of the sun, but it's in the eastern sky.
Correct, yes.
In the morning.
Yes. And then another morning observation for any early risers. On the morning of June 8th, we will see Jupiter rather close to Mercury in the morning sky. This is kind of a unique viewing condition for Jupiter. I would not recommend pointing a telescope at Jupiter in this situation when it is so close to the sun. But it is a different way to see Jupiter that isn't ordinarily how we look at it in the morning sky, shining bright next to Mercury and the sun.
Also, on June 11th is our full moon this month, and it has the nickname of the strawberry moon, and that's because it marks strawberry harvesting season. So if you want to go and do some pick your owns, make some strawberry shortcake and pies and whatever, that's a good marker for that. So keep an eye out for that as well.
And then, as David already discussed, we have the summer solstice on June 20th.
And then we have a new moon on June 25th, which will be a night that I hope is clear and that I get to be able to go out and observe, because new moon nights are great nights for when there's no disruptions from the moon with your telescope viewing, and it can often overly brighten out all of the other. It can overly brighten out the rest of the sky, and you can lose other stars, faint objects especially. And
lastly, our final thing to look out for is we're going to have the Boötid meteor shower peaking on June 27th. It's a hard to predict meteor shower. It's not necessarily the most active all the time, but you really never know. It's a good one to look out for. It comes from the Pons-Winnicke comet. And look towards Boötes, and you may see some meteors if you're lucky.
Awesome-oly. And just as a quick correction, the Jupiter and Mercury conjunction on June 8th is going to be in the evening sky.
Sorry.
That's fine. It will be in the evening sky, Jupiter and Mercury. And which is neat because so many people, even astronomers, have never seen Mercury. It's elusive. You have to go on a definite, pointed, directed hunt to try to find it. Well, Adam, Seth, thanks so much for being part of our show once again.
Thanks for having us.
Fascinating information. Hope it was nice to be had.
Indeed.
And this is The Sky This Month, and I hope that you enjoyed the show, and don't forget to keep looking up.